We're looking for the values that are not in the domain of h, and these must be the zeros of the denominator. The denominator is a quadratic, so we solve it by factoring. It factors into x plus 4 times x minus 2 equal to 0, so we have minus 4 and 2 as the excluded points. In the next problem, we are to find the domain. So looking at f, we see that the denominator is x minus 5 and we don't want that to be 0. Therefore, to get the domain of f, we just exclude 5. So the domain is all reals except 5. Graphically, that means the entire number line except the puncture at 5. As an interval, we denote this as minus infinity to 5, union 5 to infinity, two intervals, because 5 is a point of discontinuity. This is the domain of f. Now, to get the domain of g, look at the denominator. It's a quadratic, so we get its zeros by factoring. So x squared plus 6x plus 8 equal to 0 factors into x plus 4 times x plus 2, which means that minus 4 and minus 2 are the zeros, so they're out. We draw the number line and exclude these points. We then translate them into intervals, 3 intervals, minus infinity to minus 4 to minus 2, and minus 2 to infinity. And this is the domain of the function g. Okay, in this function, we should be happy because there's no denominator. The only culprit here is the square root of minus x. Square root of minus x. So minus x has to be at least equal to 0. So this means x is less than or equal to 0. We flip the inequality because we multiplied both sides by -1. We draw the graph and translate it into an interval. So the domain is minus infinity to 0, including 0. Okay, we have no denominator here, so we look for the domain of the radical. 28 plus 4x must be greater than or equal to 0. So we perform our operations and we wind up with x greater than or equal to -7. We draw the graph. So the interval translates to -7 to infinity. The next example has a denominator, so we look for the bad point, which is the 0 of that denominator. 3x plus 8 equal to 0, so this gives us -8/3, or -2 2/3. So we draw the number line and omit that -2 2/3. And remember it for later use. The numerator is a radical, x plus 6. The domain is x greater than or equal to -6, so we draw it as well. Now we look at the union of these intervals, the one with a puncture at -2 2/3 and the one from -6 to infinity. So we take the union of these intervals, the one with a puncture at -2 2/3 and the one from -6 to infinity. So we draw a third number line and mark the points -6 and -2/3. Now we shade the right side of minus 2 and 2/3, and shade it on the third number line. And then minus 6 to minus 2/3, and then the rest. From this we can create the intervals. So minus infinity to minus 6, coming from the pink shaded parts. And then the green, 6 to minus 2/3. And the yellow, minus 2/3 to infinity. That's the yellow, the green, and the pink. Inside the radical is a denominator which cannot be 0, so we have to exclude x equal to -5. Minus 6 over 5 plus x is the radicand, so it has to be at least 0. If we multiply both sides by -1, we get 6 divided by 5 plus x less than or equal to 0. The sign, the inequality symbol flips. Now less than or equal to 0 means less than 0 or equal to 0. 6 over 5 plus x less than 0 means the reciprocal is also less than 0. Multiply both sides by 6 and we'll get 5 plus x less than 0, or x is less than -5. On the other hand, for 6 divided by 5 plus x equal to 0, multiply both sides by 5 plus x and we'll get 6 equal to 0, which is a contradiction, therefore it cannot happen. Therefore, x is less than -5. We can draw its graph. It's from minus infinity to -5. And this already excludes the -5 from the denominator, so this is the domain.